PR.8 Composition of Functions and More Factoring. Southwestern College, Professor Maria Olivas. PR.8 Composition of Functions and More Factoring. Prerequisite for the chain rule. Our final derivative rule will involve composition of functions. To get ready, we need to review what that is and also some more advanced factoring techniques. In this supplement, we will review the following: compose two or more functions, recognize a function as a composition and identify the inner and outer functions, factor out a GCF when the GCF is a quantity raised to a power. 1. Composition of functions. A composition of functions occurs when the input for one function is itself a function. Notation. We're going to begin by writing f of g of x. In this first notation, g of x is inside a set of square brackets. This is going to be equal to f of g of x. In this notation, we are going to write g of x inside a set of parentheses. And this is equal to f of g of x. Here, the notation, inside a set of parentheses, we have f, and then we have like a lowercase o, but it's smaller than a lowercase o, something in between the lowercase o and maybe like a degree symbol, like it's in the middle, right in between the f and the g. And then we have the g, and then the parentheses close, and then within another set of parentheses we have an x. And then we have an arrow here pointing to the right. Here, this represents that g of x is the input into f of x. So this is the different types of notation that we like to use to represent a composition of functions. Above it, I'm going to write the way we say this out loud within quotation marks. I'm going to write an f, a lowercase f, and then the word of, and then a lowercase g, and then the word of, and then x. So f of g of x. And I have drawn arrows pointing to the three types of notation that I just wrote down from the way you would say this out loud. Now I'm going to write g of f of x. For the first one, I'm going to write the f of x within a set of square brackets. This is going to be equal to g of f of x, where the f of x is within a set of parentheses. And this is going to be equal to g of f of x, where once again here I wrote within parentheses a g, and it looks like something in between a lowercase o and a degree symbol right in between the g and the f. So that represents g of f of x, and then the x is within its own set of parentheses on the side. And then I have an arrow pointing to the right. Here, these are all examples of how f of x is the input into g of x. Example 1. Given f of x equals x raised to the third power, and g of x equals 5x plus 7, and h of x equals the square root of x, find a f of g of x. I'm going to rewrite that down here, f of g of x, and I'm going to highlight g of x in yellow. And I'm going to highlight what g of x is equal to, which is the 5x plus 7, in yellow as well. I'm going to write this is equal to f of, and within parentheses I'm going to write 5x plus 7, because the 5x plus 7 is our input, since that is equal to g of x. Before I go on, I'm going to rewrite the function for f of x above it. So I'm going to write f of x equals x cubed. So you can see here the x is what I'm substituting. In place of x, I'm going to write 5x plus 7. So every time I see an x, I'm just going to replace it with 5x plus 7. So 5x plus 7 goes inside parentheses, and then I'm going to raise that to the third power. And that's going to be equal to my composition of functions. I'm going to write this now as f of g of x is equal to, inside parentheses, we're going to have the quantity 5x plus 7, and that quantity is going to be raised to the third power. I'm going to box that in. B, we have g of f of x. So I'm going to go ahead and I'm going to recopy the notation that they have here for the g of f of x. this notation, we have the square bracket notation, where the f of x is within the set of square brackets. I'm going to highlight in blue the f of x, and I'm going to highlight in blue what f of x is equal to from our example, which is x cubed. So I'm going to first write down g of x is equal to 5x plus 7, and then below that I'm going to write g of f of x is equal to, and now I'm going to write g of, instead of the x, I'm going to write x raised to the third power, because that's what f of x is equal to. So g of x raised to the third power is equal to 5 times x to the third power plus 7. So I'm just going to go ahead and write my answer. G of f of x is equal to 5x raised to the third power plus 7. And I'm going to box that in. C, h of g of f of x. So here you see 3 functions. Now I'm going to write down what h of x is equal to. H of x is equal to the square root of x. I just happen to have found g of f of x, so I've already got part of the work done for this problem. So here I'm trying to find h of g of f of x, but I'm going to go ahead and in place of the g of f of x, I'm going to replace that whole composition of functions, and I'm going to highlight that in yellow. And I'm going to highlight what g of f of x is equal to, which is the 5x cubed plus 7. And I'm going to draw a red circle around it. And then I'm going to draw an arrow pointing to the x within the h of x function. So I'm going to write that h of g of f of x is equal to h of, I'm going to copy in 5x raised to the third power plus 7, close my parentheses. This is equal to the square root of 5x raised to the third power plus 7. So h of g of f of x is equal to the square root of 5x raised to the third power plus 7. And I'm just going to go ahead and box that in. Example 2. Given f of u is equal to 4/3 times u raised to the negative 2 power and u equals x squared plus 1, express f as a function of x. So in order to do this, we're going to substitute what u is equal to, which is the x squared plus 1, in place for u in our f of u function. And this will give us a function, f, as a function of x. I'm going to highlight the u in the f of u, and I'm going to highlight what u is equal to. U is equal to x squared plus 1. And I'm also going to highlight here where it says express f as a function of x. Let's begin by copying down f of u. So I'm going to go ahead and write down here f of u is equal to 4/3 times u raised to the negative 2 power. Underneath that, I'm going to go ahead and write f of x squared plus 1, because that's what u is equal to. This is going to be equal to 4/3 times x squared plus 1 quantity raised to the negative 2 power. So now that I've written my function in terms of x, I can rewrite this as f as a function of x. So I'm going to write f of x equals 4/3 times the quantity x squared plus 1 quantity raised to the negative 2 power and I'm going to box that in. Example 3. Given that h of x is equal to the square root of 4x minus 1 is a composition, that is, h of x equals f of g of x, identify the inner and outer functions. Let me begin by writing h of x equals f of g of x. So we're trying to identify what is g of x equal to and what is our f. Let me begin by highlighting the inner function. I'm going to highlight the g of x in yellow, and I've also highlighted the word inner in yellow. I'm going to rewrite this as this equals the square root of 4x minus 1. The inner function here is going to be the 4x minus 1 because this is the part that is inside the square root. That's going to represent our g of x function. So I'm going to go ahead and write down the word inner, and I'm going to write down the word function, and I'm going to draw an arrow pointing to the right, and I'm going to write g of x equals 4x minus 1. Now I'm going to write down the words outer function beneath where I wrote inner function. I'm going to draw an arrow pointing to the right, and I'm going to write h of u is equal to the square root of u, because that's the part that was left over that we did not include as part of g of x. I'm going to go ahead and box that in. That's going to be our answer for this problem. Example 4, given h of x equals f of g of x is equal to 1 over 3 times the square root of, and inside the square root we have 5 minus 8x. Identify the inner and outer functions. U is going to be equal to g of x. That's going to be our inner function. That's going to be what's on the inside of the square root part. We're going to call that 5 minus 8x. F of u, that's going to represent the outer function. We're going to call that 1 over 3 times the square root of u, which is also equal to 1/3 times u raised to the negative 1/2 power. Now that we found our inner and our outer function, let's find g prime of x and f prime of u. G prime of x is going to be equal to negative 8, and f prime of u, I'm going to show the work underneath here towards the bottom of the screen. I'm going to write negative 1/2 times 1/3 times u raised to the negative 1/2 power minus 2/2, and that's going to simplify to negative 1/6 times u raised to the negative 3/2 power. So this is f prime of u is equal to negative 1/6 u raised to negative 3/2 power. Part 2, factoring GCF quantities. First, a quick review of factoring out a GCF. Example 5. Factor 5x raised to the 8th power plus 9x raised to the 7th power. In this problem, you're going to look for GCF, a greatest common factor. So they both have common factors of x. I'm going to look to see which one has the smaller exponent. So I see that the 9x raised to the 7th has x to the 7th, whereas the 5x raised to the 8th has an x to the 8th. I'm going to choose the one that has the smaller exponent, in this case the x to the 7th. So that is going to represent my GCF. I'm going to write x to the 7th outside a set of square brackets. Inside the square brackets, I'm going to write 5x raised to the 8th divided by x raised to the 7th plus 9x raised to the 7th divided by x raised to the 7th, and I'm going to close the square brackets. For the next line, we're going to have x raised to the 7th. I'm going to open up a set of parentheses. We're going to have 5x plus 9 and then close the parentheses. And this is going to be our final answer. So we have factored out the GCF here. Sometimes the GCF is a power of a quantity. Remember, factor out the lower power. Example 6. Factor out the GCF. A. Here we have 10 times the quantity, 2p plus 7, and that quantity is all being raised to the 5th power, minus 5 times the quantity, 2p plus 7, and that quantity is all being raised to the 6th power. So I can see here that 5 times the quantity 2p plus 7 all raised to the 5th power. That's going to be our GCF. So I'm going to write that outside a set of square brackets. Inside the square brackets, I'm going to write 10 times the quantity 2p plus 7 raised to the 5th power divided by 5 times the quantity 2p plus 7 raised to the 5th power. And then we're going to subtract from that rational expression 5 times the quantity 2p plus 7 all raised to the 6th power divided by 5 times the quantity 2p plus 7 raised to the 5th power, and I'm going to close my square brackets. So for our next line, we're going to have 5 times the quantity 2p plus 7 raised to the 5th power. I'm going to open up a set of parentheses, and I'm going to write for our first term here 2 minus, open up a set of parentheses. We're going to be left here with 2p plus 7. I'm going to close the parentheses for the 2p plus 7, and then I'm going to close an extra set of parentheses there. I'm going to distribute the negative that's in front of the 2p plus 7. So we're going to end up with 5 times the quantity 2p plus 7 raised to the 5th power times the quantity 2 minus 2p minus 7. And then our final answer, if we simplify and we combine the 2 minus 7, we're going to end up with 5 times the quantity 2p plus 7 raised to the 5th power times the quantity negative 2p minus 5. And that's going to be our answer, so I'm going to box that in. B. For B, we have 4m times the quantity 3m plus 1 raised to the negative 5 power plus 2 times the quantity 3m plus 1 raised to the negative 6 power. In this case, the smaller exponent is the negative 6, so I'm going to circle that and I'm going to write down the word smaller exponent next to it. So we're going to write as our GCF, because not only do these both share a common factor of 3m plus 1, they also share a common factor of 2. So our GCF will be 2 times the quantity 3m plus 1 raised to the negative 6 power. Then I'm going to open up a set of square brackets. We're going to divide that first expression by our GCF. So it'll be 4m times the quantity 3m plus 1 raised to the negative 5 power divided by 2 times the quantity 3m plus 1 raised to the negative 6 power. And then we're going to add to that rational expression 2 times the quantity 3m plus 1 raised to the negative 6 power divided by 2 times the quantity 3m plus 1 raised to the negative 6 power. And then we're going to close our square brackets. After we simplify this, we're going to end up with 2 times the quantity 3m plus 1 raised to the negative 6 power times, we're going to open up a set of square brackets, 2m times the quantity 3m plus 1 raised to the negative 5 power minus, it's actually going to be the negative 5 minus a negative 6 power. And then for our next rational expression here, we're going to end up with just a plus 1. So I'm just going to write plus 1, and I'm going to close the square brackets. I'm going to close the parentheses. Now that exponent part where it says negative 5 minus a negative 6, I'm going to rewrite that as negative 5 plus 6, so you can see it's just going to be an exponent of 1. For our next line here, we're going to have 2 times the quantity 3m plus 1 raised to the negative 6 power times, we are going to open up a set of parentheses and we'll have 2m times the quantity 3m plus 1, and then next to that we'll have a plus 1 and close the parentheses. I'm going to distribute 2m to the 3m plus 1. And then we're going to have 2 times the quantity 3m plus 1 raised to the negative 6 power, and then times the quantity 6m squared plus 2m plus 1. And this will be our final answer, and I'm going to box that in. Another way we could write this answer if we wanted to simplify that negative exponent would be to write 2 times the quantity 6m squared plus 2m plus 1 all over the quantity 3m plus 1 raised to the 6th power. And I'm going to also box this answer in because this is also a possible answer for this problem.